Hello everyone, welcome to the YouTube channel Electronics Vibes. Today in this topic we will see the ideal and practical characteristics of operational amplifiers and the parameters of operational amplifier. First characteristics is infinite voltage gain. As we know that the voltage gain is the ratio of output voltage to the input voltage, and infinite voltage gain ensures that the differential input of the operational amplifier is mostly 0 for the finite output voltage V0. Infinite input resistance Ri, so that almost any signal source can drive it and there is no loading of the preceding or the previous stage. Operational amplifier has 0 output resistance, so that the output can drive an infinite number of other devices. There is no loading problem. 0 output voltage when input voltage is 0. Infinite bandwidth, so that any frequency signal from 0 to infinite Hz can be amplified without attenuation. Infinite common mode rejection ratio, so that output common mode noise voltage is 0. Infinite slew rate, so that output voltage changes occurs simultaneously with input voltage change. Now, the practical operational amplifier characteristics. The open loop voltage gain is maximum and finite. Typical value for the practical operational amplifier is 2 into 10 raised to 5. But for ideal operational amplifier, it is infinite. The input impedance is maximum and it's finite in the order of 100 kilo ohm or more. The output impedance is minimum but not 0 in the order of 100 ohm or less than it. The common mode rejection ratio is also maximum and finite but not the infinite for the practical operational amplifier. Similarly, practical operational amplifier's bandwidth is maximum and finite. It can amplify DC to 1 MHz signal. Now let's see the operational amplifier parameters. Input offset voltage. The ideal operational amplifier produces 0 volts output for 0 volt input. If there is no input voltage, then output voltage is also 0. It's called the input offset voltage. Input bias current. The input bias current is the average of both the inputs current, means the current flowing through the inverting and the non-inverting terminal is supposed to be I1 and I2 respectively. Average of the I1 and I2 current is the input bias current. It is very large. Input offset current. The input offset current is the difference of the input bias current expressed as the absolute value. Common mode rejection ratio. Ideally, common mode rejection ratio is infinite. The ratio of differential gain and common mode gain is defined as CMRR, means the common mode rejection ratio. Thus, the infinite CMRR of an ideal OpAmp ensures 0 common mode gain. Due to this, common mode noise output voltage is 0 for an ideal OpAmp, but for the practical operational amplifier, common mode rejection ratio is very high. Next is slew rate. The changes in the output voltage occurs simultaneously with the changes in the input voltage. The slew rate is very important parameter for the operational amplifier. When the input voltage applied is step type which changes instantaneously, then the output also must change rapidly as input change. If output does not change with the same rate as the input, then the distortion in the output must be takes place. Such distortion is not the desirable case. Infinite slew rate indicates that output changes simultaneously with the change in the input voltage. The slew rate is defined as the maximum rate of change of output voltage with time and expressed in volt per microsecond. Next parameter is the no effect of temperature. Operational amplifier's characteristic does not change with the temperature. Also, in this operational amplifier, power supply rejection ratio is one of the parameter which is defined as a ratio of change in input offset voltage due to the change in supply voltage, producing it keeping the other power supply voltages constants. It is also called as a power supply sensitivity. These parameters are important parameters. As per the requirement of these parameters are changes, and whatever the application we requires, for that the different IC 741 or the as per the requirement of the application, if we require the slew rate, that means output change with respect to the input, then the parameter is concentrate on the slew rate. Means we require to choose that type of operational amplifier where the slew rate is high. In that conditions, other parameters have less importance. Similarly, for the other applications, as per the requirement, we choose the particular operational amplifier and find the different applications. Thank you for watching. In the next video, we see the different configurations of operational amplifier